I'm Liz, the Split City DIY, and today I'm joined by a channel regular at this point, my computer, REPTAR. And today we're going to be doing a really special project that involves REPTAR that I'm really excited to share with you. I've actually been working on it for a really long time, but I want to kind of start from the beginning and how I kind of came up with this project. So first, in case you haven't noticed, LEDs are really popular to put inside your computer right now, whether it's on peripherals like LED fans, what I have on here, or even at this point there's LEDs on graphics cards, motherboards, RAM sticks, you name it, like there's an LED. Or there's also strips they can put around your case to kind of illuminate. But the issues that I was seeing with the strips as more and more were kind of coming out was they were either one color, which meant that if you ever in the future, changed up your color scheme, then you'd have to like buy new strips, or they were kind of flimsy, some of them, so you had to shell out a lot of money to get like one that didn't look like it was just gonna kind of snap in half. Or there was also a lot of variation in the brightness of the LEDs and also the true kind of color that you got from the LEDs as well. And then if you were lucky enough to get some RGB LEDs, which means that you can kind of change the colors of them, there was a lot of different types. They needed different voltages. They had different ways to be controlled, and only certain ones matched up with whatever hardware you had. So there was a lot to kind of consider and look at. And also, as more companies kind of caught on, yes, there are more features, but also the price kind of kept going up for more and more proprietary things. Probably the most popular one is put out by NZXT. It's called the Hue Plus. It's this little box that can sit in like your SSD rack, and all your LED strips plug in, and then there's software that you can kind of control the colors, and there's also some preset things, and there's even one thing where music can kind of cause the LEDs to react to music, and which I thought was pretty cool because I'd actually done a similar project with Arduino, and it was actually, I think it was my first project that I did with Arduino using the MSG-EQ7 chip, which is basically an audio spectrum chip where it's multiplexed 7 different bandpass filters that look at 7 different frequencies on the audio spectrum, kind of like your most common ones, ranging from low end to high end. And the project I'd done with that was I'd gotten 14 LEDs, individual LEDs, that I had 2 each addressed to each of the frequencies, and then I could hook up music to it, and it would make a little light show, and it was pretty cool. So then I started thinking like, oh, it'd be really awesome if like I could get that inside my computer. I thought, well, couldn't I, hook up my own LED strip to that and basically make my own Hue Plus that would sit inside my computer, and I'd be able to like control the colors and everything. So basically, that's what I did. And so I've shrunk down the little audio circuit so that it's right here, and that's the MSG-EQ7 chip. And then for an LED strip, I didn't go with one from a computer company manufacturer. I actually went with another from another open source hardware company called Adafruit, and this is their NeoPixel RGB LED strip. And what's really cool about the NeoPixels series is that they're addressable, which means that in the code I can call out individual LEDs on the strip to control. And also because Adafruit has a real commitment to open source software and hardware, they have a huge page of walkthroughs and guides on projects using the NeoPixels, and also their forum. People ask questions, and admins will answer and kind of help you out. And also they have their own Arduino code library for the NeoPixels that you can load in to your Arduino IDE coding interface so that you can use their own commands to control the LEDs. So when I found out about those, I thought those are perfect, and so that is what I've chosen for my strip. What I basically did in the code was replace the 14 LEDs and the pins on the Arduino with the strip. So I'm going to make another video where I talk about the whole coding process, because I'll be honest, I did struggle, and it was a kind of a lot to kind of look at and kind of work within, like how the NeoPixels are coded, but also what I needed to do to get the the chip, the MSG-Q chip to work. So there was kind of a lot of moving around, and there's still some tweaking I want to do, but for now I'm really happy with it, and I will make the code available so that if you wanted to build this in your own computer, then you can. So first, you're probably thinking, well, all that's outside, how are you going to get inside your computer? So first, I took the circuit that was in the original project here, and I shrunk it down onto a tiny little breadboard. And so that will sit with the Arduino. And how it will sit is Adafruit had a little housing that is actually the almost identical dimensions of a 3.5-inch hard drive. So that will sit right in my spare drive bay in the bottom of my case. And the Arduino and breadboard will be able to sit side by side. And then to have the Arduino talk to my computer and also power the LED strip, what I'm going to do is there's a little cable that I'll have hooked up to my motherboard that is basically a female USB header to an onboard motherboard USB 2.0 header. And this cable is by StarTech. I got it for like $2 on Amazon, and I've tested it already, and it does work. And these cables are also handy if you want to do like a bootable USB drive for Linux and have a dual boot on your system. That way your drive can just sit inside your system and you're not taking up one of your external ports. So it's really cool, and I was really excited to find it. I just kind of actually Googled to see if a cable like this existed, and I was really pumped when I found out that it did. And what's also cool is it only takes up one row on your USB 2.0 header on your motherboard. So if you want to have two of these in there for some reason, you could. And this is really handy for me because the P400 case doesn't actually have 2.0 headers on the front, so that port was totally empty for me. So I'm not losing ports by doing this. So basically, I'll have a USB cable running up from the bottom of the case to here, and it will kind of hang down about here. Now for the audio, what I'm doing is also taking advantage of the P400 I/O, and I'm going to use the HD audio onboard cable and basically plug into it. Now you'll probably see on the little circuit here, there's a little headphone jack. So in the final version of that in the case, that won't be here. I'm going to take the three pins, which are left audio, right audio, and ground, and plug into those same pinouts for the mic input on the case. So basically I'm taking audio out of my computer through the headphone output on my DAC, going into the microphone input on the case, which then through the three little cables there, we'll be able to talk to the MSG-Q chip, and we'll be able to get everything working and get the LEDs going. And the way that I found out which individual pin on here was which, I just found it on Wikipedia, and I'll link that down below in case anyone wants to do any hacks like that. And I tested that previously, and I was pumped. It worked right away. I didn't have to do any sort of tweaking or anything like that. Because I was a little bit concerned, like, oh, will like line level versus mic level be an issue, but it wasn't for the LED purpose, so awesome. So with that, let's go ahead and get started on getting this project into the computer. Alright, so first thing we're going to do is install the Arduino with the small MSG-Q circuit into this housing. As I said, I got this housing from Adafruit. Really awesome case. It was about $15, and it's really like sturdy plastic, and it even came with screws to screw two sides together, but also, if you can see here, there are these little pegs. What those are standoffs for the Arduino, similar to the motherboard standoffs in a computer case, and it comes with the screws for that, so it's really awesome. So if you need an enclosure for an Arduino project, I definitely recommend checking out Adafruit's line of stuff. So let's go ahead and get all this into the case. So the screws fit with a small screwdriver. I have a small screwdriver set from Husky, which is Phillips head, and then I also have an Allen head, and this was a really awesome way to remind myself that I've been carrying around my mini screwdrivers in my work bag for the past couple of weeks after I brought them to work so I could replace a RAM stick in a laptop. Alright, so I got the Arduino into the housing along with the circuit. There was a little kind of sticker on the back of the mini breadboard, so I just stuck it in there. I cut just some jumper wire from SparkFun because it's just a lot more stable than just the little kind of breadboard wires. It's also moldable, so like I can have it bent. And I cut these three to go to the microphone input on the HD audio pinout. So you'll see that yellow is being used to signify data flow, and then red is 5 volt and black is ground. And whenever you're setting up a circuit like this, especially one that's going to be permanent that maybe you'll have to go back to, it's always good to try to do some sort of color coding just to kind of keep it straight on what each wire is signifying, especially when you're dealing with 5 volt and ground. Now with the case, it is a modular case, and I was like pretty pumped about that, but the only thing was the screws that were included for the headers for the Arduino were a really wide head, and I was actually, it kept hitting, the header here kept hitting the pins here that actually reset the board, so I didn't attach a screw there. I would have liked to see another header down here near the power input, but there actually isn't a header for that fourth hole on the Arduino, so it's secured with the screws in the back. I think that'll be fine for my purposes, but that was something I was a little disappointed in with the housing, but otherwise pretty good. So next step's going to be wiring up the LED strip. Alright, so I just kind of finalized how the NeoPixel strand is going to be wired up, and the way I did that, this is how the NeoPixel strand comes. It has two leads for ground and 5 volt, and then it has two leads for data, although you only need one, and it's actually got, I can't get it, okay. It's got this kind of two pin, female pin out, and I read that on their site, and as a result they sell these 2-pin male pinouts. They kind of look like fan headers on computer motherboards, and so I connect those two, and that's really the only way you can get some leads off of the data from what I could see, because I tried sticking hookup wire directly into these pinouts, and it actually kind of goes through, so you do need this, and then it has two leads coming off. Now what I found was that the leads coming off for 5 volt and ground, and also for data here, they're tinned at the end, which means that a little bit of solder was put on the end, but the lead that was soldered wasn't long enough to go into something like an Arduino. And so I stripped back some of the insulation, and I found that it was stranded wire. And so I was basically kind of ruining the wire because the tin was only for like a little bit. So what I ended up doing was kind of twisting the stranded wire into some female header jumper wire, and then that are female to male, and so that's how I'm doing the ground and 5 volt. Now I could have soldered the ends to make a longer tinned lead, but I didn't, and this works just fine. Please pardon the duct tape, because at the time of when I was kind of prototyping it, I didn't have electrical tape on hand, but this has held just fine, so I'm gonna keep it that way. Now on this end though, I did pick up some electrical tape, and I taped off the unused data end here so we won't get any interference. And then, like I said before, the tinned lead, I'm using a female header, and I have that duct taped here. And then this though is a female to female jumper cable, because you actually need a 470 ohm resistor for the data pin for the NeoPixels. So I trimmed down the lead on the resistor so it was long enough to go into the Arduino board, and have it electrical taped to the female header that's attached to, and then that pops right into the Arduino board. Now, one other thing, Adafruit does recommend putting a capacitor in between the ground and 5 volt. I'm not doing that because I'm not using a separate power supply. Because I'm using the ground and 5 volt from Arduino, I'm just kind of going with that because it's pretty regulated. So that's the only thing I'm not doing that is suggested by Adafruit, so just keep that in mind. But I am doing the 470 ohm resistor. And now it's time to finish up putting together the housing and getting this into the computer. Okay, so I've done a little bit more prep. I've taken the hard drive tray out from the cage right in here, and sure enough, it fits. I also did a quick test slide in to make sure there's going to be enough clearance, and there is. If I have the wires flush, it is a really tight fit, but it fits, and that's all that matters. And then the other prep I did was I attached the leads for the audio portion of the circuit to the HD audio inputs, and I electrical taped the leads so that they wouldn't cause any interference or fall out. So that's all stable. And then to secure the housing into the tray, I actually just used a little command strip I had lying around and just put it on the front so that it could be nice and stable. So it's going to sit with the USB input turning out. So it'll be similar to the SATA to drive, so it'll help with cable management. And then I'm running the cables up here, and then this will be able to be nested in there, and then the strip will also be coming out that way too. So I'm just feeding the LED strip through this cable management hole up here. It's coming out the top in the other side of the case. Let's turn it real quick, show you. So, and the way I'm going to route it is have it come out here, down along here, and then down at the floor of the case. Okay, in an effort to respect and honor the long-held tradition and superstition that if you do anything to your computer, you should test it before closing the side panels. That's what we're going to do. I've hooked up my computer to my TV, and I have my MBox DAC on top, which will allow us to do the audio run from the computer, basically back to the computer. And yeah, so we're going to plug it in and then turn on the power supply, and hopefully everything will be okay. Okay, so now I'm going to go to devices, make sure the Arduino's there. It looks like it's looking for the internet. It knows it's a Sony TV, that's impressive. Oh. So it looks like I need the internet to recognize the device. Okay. Well, this is why we do this. Alright, I'll be back in a bit. See if I can get recognized. Okay, so did some troubleshooting, and there were two things that were wrong. One, never listen to the people that say never look at your motherboard manual, because there was a pretty big issue with the USB header to USB-A female cable. Now, I didn't remember how the cable was oriented when I originally tested, so I saw there was a little arrow pointing down on one side of the header, and there was a matching arrow on the motherboard. So I plugged in the pins in that way, and I thought it'd be fine. Now, you saw that arrow is getting like unexpected USB, need to connect to the internet, so you know, I run my Ethernet cable over, and still no dice. So finally I was like, let me just check the pinout in my motherboard manual, and sure enough is the opposite. So I don't know if whether the arrow on the cable is wrong or if the arrow on my motherboard's wrong. But either way, when I flipped that, all of a sudden LEDs came on. Now my next issue, I wasn't getting any movement with the music. So I ended up tearing everything apart. A cable had popped out in the housing, so then I got that back in, Then I still wasn't getting movement, and I was like, that's weird. What ended up being wrong, and I'm not sure why, because I'm pretty sure when I tested, I connected this pin. For some reason, ground being connected to the mic header on the HD audio header was causing everything to like not work. Now, I think that's really weird, because when I unplugged ground, it was fine. I don't think it's a big deal that I don't have ground connected to the HD audio header, so I'm just not gonna have ground connected. Maybe look into it later, but yeah, so after I did that, everything was fine. And so I just unplugged the USB cable just so you could get the idea of what everything looks like when I plug it in. So I'm gonna plug everything back up right now. Whee! Lights! So it's just general lights when there's no music playing, but when I press play in iTunes, we get some pulsing. Now I've set it to turn blue with the music, and that's because I have a blue and purple build. Obviously the LEDs look a little bit more pink right now. I'm gonna tweak the purple so it looks more purple, but yeah, it's working and I'm pumped because I was a little scared for a bit, not gonna lie. Okay, so that about wraps up this project. One last thing I want to mention is how I mounted the strip to the case. I was talking about some different ideas I had. I ended up using these Scotch mini squares that are restickable. I'm not sure if that's a real word in the English language, but fair enough, Scotch. I was a little skeptical of them. I got them because they were like fairly affordable and you get 72 squares. And I have to say, I'm impressed. They are restickable because I had to move it a bit and it didn't lose any stickiness. They're almost more of kind of a gel kind of material. They don't feel like gluey or like gross like that, so pretty good. And I just kind of put them like kind of just spaced evenly around and it's holding really well. It doesn't look like they're being like sucked somewhere. Like I'm pretty happy with it. So I know that the adhesive on some of the other LED strips are a problem, so if you have those in your case and you need a way to like restick them, I definitely give like these a try. And they have like different kinds too. I found them at Target in like the crafty section, so yeah. With that, it's been another episode of Blitz City DIY. I'm really proud of this project. Like, it's definitely one of the most fun projects I've ever worked on. It's also been one of the most challenging ones too, both from like an electronics standpoint and also like software standpoint. Like I had to put a lot of work into this, and but I'm really happy with the results. And I think you know, if you've been thinking about putting LEDs in your computer, but like you haven't wanted to shell out the bucks for like the high quality like Q+ or a whole new motherboard with an LED header on it, then I'd definitely maybe consider giving this a try, especially if you've also been thinking about like open source hardware too. And I think that's also why I love this project, is it kind of meshed my two favorite things in technology, computers, DIY computers, and also Arduino and open source stuff. So pretty pumped on it. Like I said, I'm going to be doing another video where I talk more about the coding, and I'll also be talking more kind of in depth on the tech stuff behind putting this in. I know today was more of like a how to install it and how it's working, and also a demo of how it's working, but the next video is going to go like way more in depth, and if you're like interested in making this, that video will have kind of more of the information you're probably looking for and wondering about right now. But I'm going to be throwing a ton of links down below, links to the NeoPixels, links to the MSGEQ7 chip, all sorts of links. So if there's anything that I mentioned in this video and you don't see a link for, feel free to comment below, let me know like you're looking for it, and I'll try to get it up there as fast as possible. So if you like this video, toss me a like I said, leave your questions, comments below, and also find me on Instagram, Facebook, Tumblr, and Twitter for all the behind the scenes stuff. You can also see some of the making of when I was like kind of preparing to work with this to see how it's kind of evolved. And thank you for watching. Please subscribe for similar content that's going to be coming up. And until next time, this has been Blitz City DIY.